All right, welcome back, folks. Continuing our review of what you're going to see on the free response part of the AP Calc exam. Okay, question type at a time. Today we're on to question type 3, the graphical analysis, we could call it, if we want to be technical, otherwise known as the F prime, F double prime problem. And basically the big idea here is students are given a graph of F prime, okay, the derivative, and then you're asked questions about F. Technically, could we give you F and ask about F prime, or F double prime and ask about F prime or F? Yep, that's something more common on the multiple choice part of the exam. Usually on the free response, it's here's F prime, what do we know about F? Big idea, or big ideas, I suppose, would be we can use the fundamental theorem of calculus to find values of F using areas under the curve of F prime. Okay, so we can find values of F with integrals. And then we can use the shape of F prime and what we know about derivatives to determine the behavior of F. Our key formulas will be fundamental theorem of calculus, what we know about relative mins and maxes when F prime has a sign change, and then also what we know about inflection points when F prime has mins and maxes. Let's go ahead and look at an example of that. No-cal problem. Okay, we have a graph of F prime, and it says the function f is differentiable on the closed interval from -6 to 5 and satisfies our initial condition, f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments, okay, as shown in the figure above here. All right, so we have some function f. We're not sure what it looks like. We've got a picture of f prime. We know f's starting position. And I suppose what else? We know that f prime is made up of nice lines, okay, straight line segments, semicircles. We don't have an equation for those, but we could figure them out if we really wanted to. Basically, that part of the problem just tells us things are working out nice. All right, part A, we want to find the value of f of -6 and f of 5. Okay, so really two separate problems here. First part, f of -6, what we're going to use is our fundamental theorem of calculus. And the key is going to be having an initial condition. Without that, I would not be able to tell what the actual value is. Okay, I could still do integrals. I could figure out what the net change is, but I need this initial condition to actually find f of anything here. Okay, so I've got a -2. I want to know -6. So what I'm going to do is I'm going to integrate from -6 to -2 of f prime of x dx. Okay, we can find that integral because we can find the areas between the curves. And I'm going to say that's equal to, by the fundamental theorem of calculus, f of the upper bound, -2, okay, minus f of the lower bound, the -6. All right, so filling things in then, the -6, f of -6 is what I want to know. I already know the f of -2 as it says that's a 7. And then I can evaluate this integral by just taking areas under the curves. Here we want the area from -6 to 2. So that's pretty straightforward. That's just going to be the area of this triangle here. We know area of a triangle is just half times base, so we'd say that 4 is the base, times the height. 2 is my height here. All right, so in other words, we get a 4 for that. And I suppose initially looking at this question, I'd be concerned about switching between positive and negative, especially since both our bounds are negatives. Okay, we're kind of going backwards a bit here. But nope, that makes sense. Positive 4, the curve's above the x-axis. We know we're good with that positive number. All right, then doing some algebra just to get that f of -6 alone. We can just subtract the 7 from both sides, divide by the negative. That's where we'll get 3 for our f of -6. All right, the other part, and I suppose don't forget the other part, kind of part A, 2 questions in it, is going to be to find f of -5. We can do that the same way. We'll integrate between 5 and the -2 once again. Suppose we could go all the way to -6, but let's use as little as possible. Okay, so the integral from -2 to 5 of f prime of x dx, okay, will be equal to f of 5 minus f of the -2. All right, same idea on the right side. I want f of 5. We're not sure what that is for now, but I can go minus the f of -2, the 7 right off the bat here. Okay, the left side for this integral, we've got a little more going on. Notice we've got two separate shapes. Semicircle, so 1/2 times pi times the radius squared, which in this case is 2. Okay, so 1/2 times 2 squared would just be equal to a 2 pi. And then up top for an area, we've got a triangle once again. So 1/2 times base 3 times height 2 will just be a 3 for that part. All right, now the way I'll write this then is I'm going to say that that 3 is positive, okay, because it is an area above the x-axis. Okay, but then we're going to go minus the 2 pi, because remember, the way we'll evaluate integrals is anything that's below the x-axis we'll interpret as a negative area. All right, so here's our equation to solve for the f of 5. Basically just add 7 to both sides, and that's going to leave us with a 10 minus 2 pi is what my f of 5 is equal to for this one. All right, and when I pop up our scoring criteria here, looks like this is going to be a 3-point question. 1 point for using the initial condition. Okay, so a little surprising. I expected this to be a 2-pointer, but basically by using this f of -2 equals 7, I'm assuming we'd have to do it for both cases. We're going to get a point. Okay, and then the final point for these answers, f of -6, f of 5, and I'm assuming if you forgot that piece, you won't have the right answer, so you get 0 points. Okay, so obviously important with that there. All right, question B asks, on what intervals is f increasing? Okay, well, increasing means moving up from left to right. And as far as derivatives go, that means when is f prime greater than 0? Okay, so here we're looking for the parts above the x-axis. I can tell I have one part of my function f that's going to be increasing here. It's terrible looking. Let's see if we can do a little better with that. And another interval of increasing where our derivative is positive here. All right, so our answer then is going to be increasing on, let's say, -6 to -2 and 2 to 5. Okay, so those are my increasing intervals. Now, AP exam's not going to be picky about is this a bracket, a closed interval, or an open interval. Okay, that's a little bit open for interpretation. We'll use them as open here. Okay, so on what intervals are we increasing? We've got the answer for that. Now notice here we have this justify your answer. So in other words, explain in terms of calculus why we know it's interval. Okay, so we'll say it's increasing on these two intervals because we can say that f prime of x, the derivative, is positive. Actually, I lied. I don't want to say is positive. That's technically correct, but let's use some more math notation here and be more concise. Instead of is positive, we'll say, in other words, is greater than 0 on those intervals. Okay, so that should work for the proper intervals and justification. Now, we don't need to explain anything further than that. We don't need to teach the reader this question calculus. Okay, we'll assume the reader knows how calc works. Okay, so we'll just tell them what we looked for where our derivative was greater than 0 is how we knew these were the correct intervals here. And then for the scoring, 1 point for the answer, 1 point for the justification. Okay, so if we get those correct answers, we get the +1, the correct intervals. And then as far as the justification goes, that's the other point. Now I believe you'd need the correct answer, the correct intervals to get that justification point. But that second point's not too much of a stretch there. Common thing you'll have to justify. All right, part C, find the absolute minimum value of f on the closed interval, -6 to 5. And again, justify your answer. Okay, so we've got our derivative function. We know that the local or relative mins and maxes are going to take place when our derivative crosses the x-axis. So it looks like we have a local, let's see, this will be a maximum at x equals -2. Because my derivative goes from positive to negative, meaning the function will go from increasing to decreasing. Then same idea here, we've got a local min at x equals 2, because my derivative is going from negative to positive, because the function will go from decreasing to increasing. Okay, so those will be the local. As far as the absolute, we know it's going to be either a local min or max, okay, or one of these two endpoints, -6 or 5. All right, so this question, I think it's easiest to start with the justification part. Let's write out what we're looking at, what we're doing. Let's say that the absolute minimum will occur at a critical point where we want to say critical point of what? What is the critical point? That's going to be where f prime of x is equal to 0. Okay, or at an endpoint. Okay, so that's my justification. That's essentially my extreme value theorem. Okay, how do we know that the value we come up with here is the absolute minimum? Okay, because based on this. Okay, so what we need to do is we need to consider our critical points. Again, that's going to be where our derivative equals 0, and we have 2 of those. Easiest way to express us kind of taking this into consideration is I'm going to say I know that f prime of x equals 0 when x is equal to -2 and 2. All right, and then from there what we'll do is our candidates test, and I'll just move up here because I've got some space actually. We're going to look at x and f of x values, and we need to consider the first endpoint, the -6, our 2 critical points, -2 and 2, and then our last endpoint, the 5. And I'm going to say most of this work is already done for us. F of -6, that was the first thing we found in part A, and I believe that was a 3. All right, f of -2, we're given that in the question, that's a 7. All right, f of 2, I suppose I don't know that right off the bat. Yep, that'll be the new one we have to actually evaluate. F of 5 then is, we got that earlier as well, that was the 10 minus 2 pi. Okay, so I suppose the last thing we want to do is figure out this f of positive 2. Just like we did earlier, we could go integral from -2 to 2 of f of x dx. Okay, that's going to be equal to f of 2 minus f of negative 2. So we're kind of running out of room here. Integral from negative 2 to 2, we've already done this. This is just half pi r squared, so 2 pi. So I could say that 2 pi is equal to f of 2, which is what we're looking for, minus f of negative 2, which is the 7. What do we screw up here? We know that this is going to be a negative value, okay, because we're below the x-axis once again. All right, so add 7 to both sides. That's going to give us that f of 2 is equal to a positive 7 minus a 2 pi. Okay, well, 7 minus 2 pi, I know that's going to be greater or less than 10 minus 2 pi. I know it's going to be less than the 7. Now, is that less than 3? Okay, well, 2 pi is about 2 times 3. It's a little more than 2 times 3, so this will be less than 1, we know. Okay, so there's our winner. And we want to explain what we just found. We'll say absolute maximum or minimum of, we'll say 7 minus 2 pi. Okay, and this is asking for the absolute min, okay, not the x value of the absolute min, but we'll say that anyways. But this is technically just the answer we're looking for, okay, at x equals 2. Okay, so do pay attention. Are we looking for the value of that absolute min or max, or just the x value it occurs at? Okay, here we're looking for the value. All right, then finally with this one, the scoring piece, 2 points only. Should add a t there. There we go. First, for considering x equals 2. Okay, so recognizing that x equals 2 is a possible min or a max. And again, we know that it is a local minimum. And I suppose considering also includes evaluating it here. And then the second point will be the answer with the justification. So that would be having the correct answer here with our justification, explaining the extreme value theorem, talking about where our zeros are, and then showing what we checked. Okay, so no points for just the answer for this one. You got to justify as well. Seems like kind of a lot of work for 2 points, but when you consider I found most of these already in previous questions, 2 points seems about fair. All right, last question, part D finally. Here we want to know for f double prime of negative 5 and f double prime of 3, we want to find the value or explain why it does not exist. Okay, so here's an example. We're going from the derivative to the second derivative. Let's start off with f double prime of negative 5. Okay, that's going to be the more straightforward one here. Okay, for that, we've got our negative 2, 3, 4, 5 right here. Okay, and f double prime of negative 5 is going to be the derivative of our f prime. Remember, derivatives are equal to the slope of the tangent line. Well, what's my slope at x equals negative 5? That would just be rise over run. It's down, so we'll say negative 2 over a run of 4. Okay, which is equal to just a negative 1/2. All right, I suppose we could have been more technical if we had points and used a difference quotient where we went y2 minus y over x minus x. But here it's okay to just count. Now, as far as find the value or explain why it doesn't exist, it doesn't say to explain why this is this. We'll just say there's our first answer here. All right, second part, let's take a look at what's happening at f double prime of 3. Well, f prime at 3, notice we have a sharp corner. Okay, we have an edge. We have a spot where the graph's not smooth. Okay, so that's why we know that at x equals 3, we're not differentiable. So in other words, what would we say about f double prime of 3? We'd say it does not exist. Okay, but not good enough. Why it does not exist, we have to include that. Okay, so as far as an exclamation goes here, usually this is covered within multiple choice questions, and we're just picking the spots that are not differentiable, the spots with the sharp corners, like at x equals -2, x equals 2, and the 3 here. But for a justification, a calculus-based justification, it's not enough just to say that there's a sharp corner there. I mean, if it came down to it, you could put that down and cross your fingers, hopefully get the point for it. Probably not. What we'd want to do is we'd want to say, well, I can tell that the derivative leading up to 3 on the left side is looks like +2, whereas on the right side it's a -1. Those are my slopes. Those are not equal here. Okay, the technical calculus way we'd say that is we'd say because the derivative, or limit in other words, the limit as x goes towards 3 from the left side, the negative side, of our definition of a derivative at a point, f prime of x minus f of 3, and that'd be a prime, over x minus 3. So as we get closer to the 3 from the left, our derivative is equal to, we said it's up 1 over 2, a 2, which is not equal to the derivative on the right side of the 3, which is a down 2, right 2, a -1, which is the definition of the derivative on the right side of that f prime of x minus f of 3, okay, over x minus 3. Okay, so in other words, our derivatives coming from the left and the right side here are not equal to each other. And then finally, looking at the scoring, 2 points, pretty straightforward. 1 point for our f double prime of -5, kind of the easy point for this one. And then a second point for why it does not exist at f double prime of 3, along with the explanation. Okay, is this explanation maybe a little beyond what you're going to get, especially with a time limit? Yeah, probably. But like we said before, if you're getting 2 out of every 3 points on this exam, you're doing awesome. You're on pace for a 5. Okay, so if you missed just that last point on the question, you got the other 8, you're doing pretty darn good. All right, that's the, what do we call it, the graphical analysis, aka the f prime, f double prime question. Okay, a lot of common themes that show up within different free response questions as well as multiple choice. Okay, so hopefully that gives you a little refresher of how all that stuff worked mixed together here. We'll see you next time.